Hi, and thanks for joining Sapelo Nerds, a coastal science podcast. I'm your host, Corinne.
And I'm your host, Brittany. And we work at the National Estuarine Research Reserve, or NERR, on Sapelo Island, a Georgia barrier island.
If you've been listening to our podcast for more than a couple of episodes, then you should know that we're kind of science nerds.
I mean, nerds is in our name, after all.
Exactly. So today, we want to tell you about another super cool place on the coast where wonderful coastal science nerdiness is thriving. We're diving into the work happening at the Skidaway Institute of Oceanography, part of the University of Georgia's coastal research efforts.
That's right. We've talked a lot about UGAMI, or the University of Georgia's Marine Institute, here on Sapelo, but the Skidaway Institute of Oceanography is another coastal facility of UGA, but with totally different focus. Instead of salt marsh and estuarine research, the Skidaway Institute focuses on interdisciplinary oceanographic research around the globe, and in Georgia too. There are 10 full-time faculty at Skidaway that conduct their research in state-of-the-art specialized laboratories. These research facilities can zoom into microscopic plankton or all the way out to satellite imaging. To name just a few of these facilities, there is the Laboratory for Imaging Microbial Ecology, there's the Stable Isotope Analysis Lab, the Trace Metal Lab, the Small Satellite Remote Sensing Lab, and the Southeastern Coastal Ocean Observing Regional Association, or SOCORA, funds gliders and coastal wave radar monitoring in the ocean in the southeastern United States.
And it's at a prime location for these studies as well. It is located on Skidaway Island near Savannah, so it serves as a hub for cutting-edge coastal research in the 4 main categories of coastal science, which of course are biology, chemistry, geology, and physics. Within these categories, the Skidaway Institute of Oceanography conducts research across a broad range of focus areas, covering not only local economic and environmental issues, but also global processes and phenomena.
And the researchers can do so many fascinating studies, not only thanks to the state-of-the-art facilities, but also because of the fleet of research vessels, ranging from small skiffs suitable for inshore work, up to the 104-foot ocean-going research vessel Savannah, which operates primarily in ocean waters above our continental shelf, from Delaware to the Gulf of Mexico. These vessels are used by the Skidaway Institute researchers as well as scientists from all over the world.
The Institute is committed to advancing our understanding of coastal processes, from estuarine dynamics to bottom-dwelling or benthic biology, and everything in between. Skidaway scientists are actively studying the effects of climate change on coastal ecosystems, including sea level rise, storm intensification, and changes in ocean circulation patterns. By combining field observations with sophisticated computer models, they're gaining insights into how these dynamics will shape our coastlines in the decades to come.
Dr. Clark Alexander, the director of the Skidaway Institute of Oceanography, and a coastal and marine geologist, has been utilizing models for over the last several years to help us understand what Georgia's barrier islands will look like in the future. Predictions of sea level rise over the next century vary from roughly 1 to 6 feet, and although scientists disagree on the ultimate height of the rise, they all agree that saltwater is moving inland and will continue to do so for the foreseeable future. Here on the Georgia coast, islands will become smaller and hammocks, or small islands surrounded by marsh, will disappear entirely. Salt marshes will be inundated by the rising waters and migrate towards the uplands, and some low-lying uplands will become salt marshes. To predict the extent of these changes, scientists are using the Predictive Sea Level Affecting Marshes Model, or SLAM, which was originally developed for the U.S. Fish and Wildlife Service.
So SLAM predicts the effects of future sea level rise based on 2 key inputs: an elevation map of the coastal zone and salinity profiles up the rivers and waterways. Salinity, or how much salt is in the water, and elevation are 2 key factors that determine the type of plants, and thus habitat, that will be present at any particular location. Dr. Alexander and his team began studying the 5 key river systems along the coast and numerous salt marsh estuaries in 2013. Salinity along the coast is dominantly affected by river discharge into the estuaries. So the team began conducting its surveys during both winter, when more fresh water is flowing in from rivers, and the summer, when less fresh water is flowing in from rivers. So, Brittany, can you tell us what they found?
Well, let's ask the professional. Hi, Dr. Alexander. Thanks for being on the show today.
Hi, I'm very glad to be here, and thanks for inviting me to come talk about some of the work that we've been doing in coastal Georgia. As a little bit of background about myself, I'm a coastal geologist originally from California, so I started out in a very different kind of coastal setting.
Very different.
Getting my undergraduate degree at Humboldt State in Northern California, and then moving to Raleigh to NC State, where I did my graduate degrees, learning about this kind of a coastal environment, which differs so much from the active geological setting that we have on the West Coast.
So what did your 2015 SLAM modeling tell us about Georgia's changing coastlines and how things have changed since then?
So this 2015 modeling, which was done in conjunction with Dr. Christine Laddick at Georgia Southern University, showed us that the salt marshes are migrating inland, as is generally predicted. As sea levels rise, more salt water goes up the rivers, and that drives the freshwater swamps and the freshwater tidal areas further up into the riverine corridors and allows salt marsh to move further inland because there's salty water to allow it to grow. And so we did see that there are areas that are projected to change and that there are areas of upland that are transitioning into salt marshes over time.
Oh, that makes sense. Absolutely. And as a coastal geologist, I've heard that you're the man to ask about the earthquakes of the Southeast, which I feel like many of our listeners might need me to say that again. Yeah, we do have earthquakes.
Yeah, that's a really fascinating subject. We do have earthquakes here. They're just not as frequent as you do in, say, something like California or West Coast or more tectonically active settings. Mm-hmm. The last large earthquake in our area was in 1886 in Charleston, in Orangeburg really was the epicenter, but it did significant damage. The estimated magnitude was about a 7.3, so it's a large earthquake. Mm-hmm. And the amount of energy that was transmitted and arrived at Savannah after that earthquake is estimated at about magnitude 5. So we did see some impacts here in Savannah. Sometimes when you go down to River Street, you'll see there are some buildings that have those earthquake through bolts still on some of the older buildings, which stabilizes them. And it actually shifted the Fresnel lens at the top of the Tybee Island lighthouse a few inches, even though it weighs several tons.
Wow, that's impressive. And I know we talk a lot about coastal dynamics here and about the many projects going on in coastal Georgia. And it seems like the Institute is involved in so many different research projects at one time. What are some projects that have come out of Skidaway that you feel have had significant impact on our understanding of our local ecosystems?
Well, Skidaway Institute focused very closely on understanding the ecosystems on the continental shelf in the coastal ocean here. That was really one of the areas that we focused on intensively when the Institute was first founded. The Savannah River site, a nuclear weapons production facility, is located up in Augusta/Aiken, South Carolina. There was a concern that there might be releases of radioactivity from that area in the future, and so we didn't know anything about what the ecosystems were and how such a release might impact the coastal ocean. And so there was a lot of work done to understand those basic environments and understanding what animals lived here, what the current patterns were like, where did the nutrients come from that fed those ecosystems, so we could understand what impacts to those ecosystems would be. In the more recent past and continuing now in the current day, we have projects that are looking at the importance of specific organisms, in this case doliolids, which are sort of like little jelly organisms which are not easily collected, that are not easily studied, because whenever you grab them out of the water, they just turn to mush. And so we have new techniques and new tools that we're using that image them in place in the ocean so that you can understand how they are interacting and how they are important in the food chains that exist right now.
Wow. I didn't realize that Skidaway had such a historical impact for studying those coastal shelf ecosystems. But definitely sounds like some really interesting new research that's going on. Probably some new future podcast episodes.
Yes, definitely. Would have to practice saying Doliolid a little bit more.
So what are some other projects that you're most excited about coming out of the Institute now?
Well, we have a number of very exciting research projects that are going on right now. One I'd like to highlight is the Glider Network, which is run by Dr. Catherine Edwards. And that basically, these gliders look like yellow torpedoes, and they glide through the water collecting salinity and temperature information, which is very important for feeding into models for hurricane intensity. Right now, we drop sondes from airplanes, we look at surface ocean temperature with satellites, but that doesn't tell you about how much warm water is underneath the hurricanes, which can lead to rapid intensification. And the addition of this kind of data from the gliders, which can fly under the hurricanes and then radio back their data, has led to much better forecasts for hurricane path and intensification in the future. One of the other really exciting projects is a large-scale project that Dr. Cliff Buck and Dr. Dan Onimus are part of. This is called the Geotraces Initiative. It's a global project which is measuring the chemistry of the oceans throughout the ocean basin. So recently there was a cruise that went from the Gulf of Alaska down to Hawaii, and then another cruise later on, also several months long, that went from Hawaii down to Antarctica. The scientists are on these ships for long periods of time, collecting information about the distribution of important micronutrients and, in general, the chemistry of the ocean. Dr. Buck focuses on the input of iron from the atmosphere. And as many of your listeners will know, iron is an important micronutrient that lets phytoplankton be able to grow. And the phytoplankton produce about half of the oxygen that we breathe. So that's a very important parameter to understand. Dr. Onimus looks at those particles that come in from the atmosphere and that get formed in the water column, and basically looks at how they change over time, which has a lot of impact on how do we cycle carbon, how much carbon leaves the photic zone where it's produced, which can have significant impacts on the global carbon cycle, which, as we all know, feeds into climate change and our understanding of what will happen in the future. Further, we have a satellite oceanographer here at Skidaway Institute, Dr. Sarah Rivero-Calle, who is working with satellites called CubeSats. They're about the size of a loaf of bread. They go up typically with just one mission. The one that's up there now that she's using is looking at ocean color, so that she can look at spatial patterns of phytoplankton productivity and understand what is driving the productivity of these plankton. As we mentioned, the productivity is so important. And so here at Skidaway, we actually focus on the base of the marine food chain. We're looking at phytoplankton and zooplankton. We really don't look at things that are much larger than larval fish, but we're trying to understand the base of the food chain, the primary producers, and then others look at how that is translated into larger organisms.
Yeah, that's so much fascinating work. And it sounds like you have so many different people and aspects to study this really important work and these really small factors that we may not think about having huge impacts. So there might be some other partners or people that you work with and studies that you do along the coast here.
And yeah, listeners may remember our last episode with Mary Quinn from Gray's Reef National Marine Sanctuary, and how they just got a brand new research vessel. Its home port is right here at Skidaway, correct? What is your relationship with Gray's Reef?
Yes, so Gray's Reef has had their offices here at Skidaway Institute of Oceanography for decades. They've been a very important partner for us. NOAA is a strong supporter of ocean science, as most of your listeners will know, supporting SINER and Gray's Reef and the the coastal management program here in the state, which funds a lot of important research as well. Gray's Reef, because we are able here at the Skidaway Institute to support their marine operations, and they spend a lot of time going out to their reef to study it using scuba diving, their smaller vessels, which they've had in the past, has not allowed them to stay out overnight and look at processes that occur on day to night cycles, or to stay out over longer term periods, or to even go out when the weather is rougher and is a nice calm day. So this new vessel, which is about 50 feet long, has much more stability, has a few berths so they can stay out overnight, and so it will really enhance their ability to do science. And we're happy to host it here at the Skidaway Institute.
And so a lot of not only having partners involved, but we see that a lot of the work that's going on through Skidaway is in partnership through the Coastal Incentive Grants program. Can you talk about the CIG and the work you've done through their program?
Sure. The Coastal Incentive Grant Program, which is funded by NOAA through the Coastal Management Program here in Georgia, which is based out of the Coastal Resources Division of DNR.
Our sister organization.
Yes, exactly. They are very forward-looking in their use of the funds they get for the Coastal Management Program here in Georgia. They put about half of their budget into very applied research that answers management questions that they have, and the outcomes of which provide data that they need to better manage the Georgia coast. For example, I've had a long working relationship with DNR and the CIG program. Right now, we've got two projects going on. One, which is measuring the accumulation rates in the salt marshes of Georgia. We're trying to see whether there are areas that are accumulating more rapidly and some that are accumulating less rapidly.
Could you define accumulating for our listeners?
Sure. So, as we all know, the water is very muddy here in Georgia. So we have a lot of suspended sediment. When it's high tide and that water comes up onto the marshes, some of that sediment gets left behind, it settles out, it's baffled by the marsh grass, and as that sediment, it accumulates on the surface of the marsh and allows the marsh to build up over time. And one of the fundamental questions that we have in the Southeast and in Georgia in particular is that we know sea levels are rising. We know how fast they're rising because of data that we measure at, say, Fort Pulaski National Monument, where there's a NOAA tide gauge, and in Fernandina Beach, where there's another NOAA tide gauge, where they carefully monitor the rate of sea level rise. And what we want to understand is, are the marshes accumulating as fast as sea level is rising? Because if they are, then they will stay healthy over time. If they're not, then at some point these marshes are going to start fragmenting, start drowning, and we will have less salt marsh over time, which would be detrimental to the ecological health and, frankly, the physical health of a lot of the upland properties that benefit from the baffling of wave effects that we get from salt marsh grass. So we are studying how fast the marshes are building up. The data we have so far suggests that the marshes are not building up as rapidly as sea level is rising, and it appears that sea level rise rates are increasing as we are moving into the last few decades, going up, and the projection is that they'll go up by a factor of 2 or 3 above what has historically been the case.
Oh, wow.
So this is something that we need to be thinking about in the state. And one of the forward-looking outcomes of this project about marsh accretion is if we can identify areas that are near the intercoastal waterway where we have to dredge anyhow, there are techniques for spreading that sediment on the marsh, giving it some elevation, and being able to beneficially use some of that sediment. So that's kind of a win-win. We keep the intercoastal open, and we are able to let our marsh persist. One other project I'll just mention is that although we know where good beach quality sand is seaward of the developed barrier islands, Should we need to renourish beaches such as they do at Tybee and they've been talking about doing on Jekyll and St. Simons? We have a lot of barrier islands here in Georgia which are undeveloped. So obviously no one is ever going to come in and say we need to protect our upland infrastructure here. If a beach gets destroyed or we have significant erosion, no one is going to come in and pay to put that beach back. But because many of these sites are national wildlife refuges, they are heritage preserves, they're state-owned, they're privately owned. There is a lot of important habitat there for things like sea turtles and migratory waterfowl and a lot of threatened and endangered species. So we might need to rebuild coastal habitat for those kinds of species should those habitats get wiped out during large storms. And so we really don't have a good idea where beach quality sand is offshore of our undeveloped islands. And so right now we're going out and taking sand samples from all these beaches and taking sand samples within state waters, 0 to 3 miles from shore, and analyzing those sands to find out where sands of an appropriate size and color and character are located. So if we need to get sand, we know where to go get it. And so you can see these are very applied projects, but they have very important management implications for better management of the coast.
Yeah, and all of our listeners should know by now, if you listen to any of our episodes, how important our coastal ecosystems are and the habitats that it provides. So, Dr. Alexander, with all those projects, you guys still have numerous students, both undergraduate and graduate, who come through the Institute every year, correct?
That's absolutely correct. We have a stable group of graduate students that are here full-time, year-round, working with the Skidaway faculty. All the Skidaway faculty are faculty in the Marine Sciences Department up at UGA, and our graduate students are all graduate students in the Marine Sciences Department at UGA as well. You might just think of us as a remote extension of the UGA campus down here. So the students that are here, we have about 15 of them constantly here on campus. And one thing that we're very excited about is the first full-time residential undergraduates being here on campus. There's a new UGA undergraduate ocean science major that was only approved in 2020. So we've been building those undergraduate student numbers. But one of the great things about that program that we see here at Skidaway Institute is that all of those ocean science majors in their the fall of their senior year, they come to Skidaway, spend their whole fall semester here, taking hands-on courses, getting out in the field on our research vessel, and going out into the field, getting into the environment and getting some very hands-on experience. This is part of UGA's strong emphasis in experiential learning. And so we think it's very important, and it provides valuable skills to these ocean science majors that they can't really get anywhere else.
That does sound like some amazing opportunities for undergraduates and graduates who get to do research down here. And sounds like some really fascinating projects that you have going on all over the facility as well. So it's really exciting to have you on and kind of introduce us to the Skidaway Institute.
We mentioned really briefly just, about the facilities that you have, but especially the RV Savannah. Would you like to talk a little bit more about that?
Yes, I'd really like to talk about the RV Savannah. This is part of the academic research fleet that is funded by the National Science Foundation. There are about 17 of these vessels around the nation, and ours is the only one between Miami and Delaware. So if you want to do scientific research in the region between those two, you come and you use our research vessel. It's a relatively small vessel for the academic research fleet, but it is a very capable vessel working out into the Atlantic Ocean, as I say, from Delaware to Miami, and then it has done a lot of work in the Gulf of Mexico as well. The research vessel is currently in Charleston in the shipyard getting its midlife refit, which is something that all seagoing vessels do about every 20 years. So it's getting new engines, new generators. We're adding 12 feet onto the length of the vessel.
Oh, wow.
So it'll be 104 feet long. The reason we're adding more length to the vessel is that in this day and age, many scientists like to bring their own labs with them, and they just build their labs into 20-foot shipping containers like you see on big trucks on the freeway. And so they'll build their lab into that container. They'll just deliver that to the ship, and it gets put on the ship. But our ship was too short to hold those 20-foot containers, and with the addition of these 12 feet, we'll be able to hold them.
Oh, wow.
You know, that
really makes a mobile lab.
Yeah.
Yes, exactly. In the old days, we would have to ship all our gear to the ship, and then you'd spend the first 6 or 8 or 12 hours building out a lab in the ship, to making the best of what space was available. And this is just a step forward in how you do science at sea.
Mm-hmm. I'd much rather think that I'm driving next to a mobile lab as I'm going down the highway than just random
shipping
other
containers. Well, thank you so much, Dr. Alexander. That was fascinating information.
Well, I've really enjoyed being here. And do you guys want a geology pun?
Sure.
Well, I can try to dig something up for you.
Nice.
It was definitely great having you on our show today. And we'll let you get back to your work at the Institute now. You want to keep those A students busy. Wouldn't want to get them below sea level.
Wow. Wow, Corinne, you've really hit the geology joke floor with that one.
Geology floor, they have one here? Where's that?
No, it's rock bottom.
I don't think we've hit the dad joke rock bottom yet. We can keep going. How did the robber prevent coastal erosion?
I don't know how.
He held up a bank.
Wow.
For more information about any of the topics we covered today, or to submit your question that may be featured in our upcoming episodes, please email us at signer.socials@gmail.com. That's SINERR.socials@gmail.com.
Thank you for listening to Sapelo Nerds, a coastal science podcast brought to you by the Sapelo Island National Estuarine Research Reserve. Please check back for more episodes released each month. And we really need reviews, so, leave us a couple of good ones. Really good ones.
And that's the Sapelo Sound.